Hey guys, welcome to the CS Classroom. This is option C, Web Science. Now, before we get started, I've got a few notes about this particular option. First of all, this is an exhausting information dump. You're just going to have to memorize like a massive amount of information. So there's not really much problem solving, but you just need to memorize stuff. Now, the most difficult part of this option is the PHP, HTML, and mySQL content. Basically, you need to understand at a basic level how PHP and HTML work, which in my opinion is overkill for this option and makes me wonder why I did this to my students, but it is what it is. One of the benefits of this topic is that it overlaps heavily with topic 3, which is networks. So the first couple of slides, which are heavily related to stuff you should have already done in topic 3, I'm going to be going through pretty quickly. Kind of a cautionary message as well is that there is the HL content included, but just the HL content by its very nature for this option is kind of random and weird. So just kind of keep that in mind as you're going through it. The study guide will not be out at the time of the release of this video. I'm kind of prioritizing releasing this video because I know that the IB exams are upon us, but within a few days of the release of this video, a study guide should be out, which I think is particularly important for this topic given the volume of just content to be covered. That being said, let's get started. Now, the first thing we're going to start with is what is the internet? Given that this topic is web science, it makes sense to go through this first. So the internet is a very large global network that allows users to access the World Wide Web. So an important distinction to be made is the fact that the internet is the infrastructure or the hardware that manages the flow of information and basically composes this network that we call the internet. So the internet is the hardware. The World Wide Web are the actual web pages and websites that are stored on the infrastructure of the internet. Now, specifically when we say the internet is the infrastructure, we're talking about computers and devices that that basically form the network, right? So you have computers, and these computers are connected to each other through wired and wireless connections via switches and routers. And if you remember from topic 3, we've got data interchanges, we've got ISPs that basically compose this network and allow us to transmit packets from one end of the internet to the other. So again, just to repeat, the internet is the infrastructure or the hardware that composes this network, this global network. And the World Wide Web is the collection of all the web pages, basically information that's displayed on the internet and can be accessed in a browser. So www.google.com, that actual web page, that's the World Wide Web. However, your ISP and all the hardware associated with your internet service provider, that is part of the internet. That is part of the hardware, the infrastructure. And to kind of drill more specifically into the World Wide Web and how we talk about web pages, a website is a collection of pages on a specific topic, so google.com. Or a web page is an individual page in a website, so google.com/email or something of that sort. Again, this slide is actually taken from topic 3, so if you don't fully understand this, I'd recommend going back to that video where this is explained in more detail. Now, we've got another slide here comparing the internet and the World Wide Web. As we said before, the internet is devices, the World Wide Web is websites. So the internet can be accessed on all devices, versus when we're looking at the World Wide Web, we're going to need a piece of software called a web browser to view the content, to view that web page. This distinction we've already gone over, devices versus websites again. And given that the internet is focused on the hardware, we're going to be using protocols like TCP/IP. We're going to use DNS, email, and FTP, file transfer protocol. However, the World Wide Web is purely talking about websites, so those are going to focus on mainly HTTP. So websites are not all that's on the internet, right? We can also send emails, we can transfer files, we can instant message each other, and those aren't specifically part of the World Wide Web. Those transactions don't take place through web pages. And so we have other protocols that still function on the infrastructure of the internet and allow us to do different things besides just viewing and interacting with web pages in a web browser. Now, we're going to talk a little bit more about the internet in depth here. So we kind of went over this in topic 3, but not as much. But the bottom line is that every website is stored on a server. So whether we're talking about Facebook.com or Google.com, we're basically talking about a computer. Now, Facebook.com may be a computer that's actually just in front of 100,000 computers behind it, but at its core, every website is stored on a server, and each one of those servers has an IP address. So even Google.com, we can actually look up the IP address and just use an IP address to access the website in our browser. Now, when we access a website from our web browser is sending a request to that server for its contents. It's basically sending a little message to the server at the given IP address that, hey, you want to see what's on that server, or you want to see what's being displayed, what HTML, what web page is being displayed by that server. Now, I know we type in www.google.com instead of an IP address like this, and we'll get into the details of how that works. Basically, what happens is when you type in a URL, that gets translated to an IP address, and your web browser then takes that IP address and sends it off to a server to make a request. Now, this part we already know. Data is transmitted across the internet using data packets through switches, routers, hubs, etc. that make up the internet. And basically, this request that's being sent from your browser to a server goes through that infrastructure on the internet. Now, what we're going to talk about in a second here is going to be HTTP requests, which are basically those requests that you send to a web server in order to get information. Now, I know this diagram looks a bit convoluted. Basically, how this works is, this is you right here at your computer. You are the stick person. This is your way of connecting to the internet right here, okay? We don't really have dial-up anymore, but that used to be an option, right? That's your way of connecting to the internet. So through the internet, you're going to send something called an HTTP request. That's basically a message saying, hey, I want to access this website. That HTTP request gets sent to your internet service provider, which passes that on to a particular server on the internet. So that's this right here. Now, that message is in the form of packets that make up your HTTP request. Now, when that request is made to a server, that server sends back a response in the form of HTTP, although TCP/IP is being used as part of that. And so from, let's say, Facebook.com, we're sending an HTTP request, or an HTTP response, and we can say that that's kind of being sent back to your ISP and then back to your computer. So really, what we're doing is we're sending a request to a server, and then we're receiving a response back. And this ISP and the fact that we're going to a server, that's all more hardware related, right? Now, I know this diagram is a bit complicated. I just honestly couldn't find a better one, but we'll look at some simpler examples as we go on. Now, we've talked about HTTP and TCP/IP, and these are examples of protocols, and you do need to know what protocols are. That's a question that comes up very commonly on the Option C exam. So protocols are a set of rules and guidelines that govern how data is transmitted, received, and processed across a network. So these define the format, the timing, the sequence in which information is transmitted, and any error control to make sure that the data transmitted is correct over the network. Now, some examples of protocols are TCP/IP, HTTP, FTP, which is file transfer protocol, which you don't use so much anymore, but that's kind of just for sending files over the internet, and SMTP, which is simple mail transfer protocol, which basically underpins any email service that you're using. Now, these two we're not going to look into. SMTP and FTP we're not going to look into very much, but we're going to spend time with TCP/IP and HTTP because these are what allow us to make transactions over the internet and specifically to work with web pages on the World Wide Web. Again, this is a topic 3 topic, so if you don't fully understand this, I'd really recommend going back to topic 3 where this is explained in more detail. Like, honestly, this option C kind of assumes that you've already covered the paper 1 content. Now, protocols are important like TCP and IP because they, in a nutshell, allow successful communication to take place. They also allow us to make sure there's no errors in data that's transmitted. They allow us to regulate the speed of packet flow so that one device isn't sending information at a rate that is faster than the receiving device can receive it. And they manage packet switching, which is that crucial process by which we can divide information up into packets and transmit it through multiple routes across the internet. Now, getting back to what we were kind of talking about when we were discussing IP addresses. The way that we generally access websites on the internet through a web browser is through a URL, which stands for Uniform Resource Locator. Now, an example of a URL is something like www.google.com. So this is a typical address that you might type into your web browser. Now, every URL has a protocol, a domain name, and a web page or file name. And you do need to know what these are. You may be given a URL and asked to dissect them into these particular components. Now, right here, this little HTTPS part, that's going to be the protocol. The domain is going to be everything from www to .com. The path you don't really need to worry about as much, but after that, after the slash, you're going to have your web page name. And those are the components that compose a URL. Now, you might run into something also called a URI, or a Uniform Resource Identifier. Now, all URLs are URIs, but not all URIs are URLs. URLs are meant to allow you to access a resource so that you can type a URL into your browser and then see that. URIs simply identify the location of a resource. So for example, right here, we have a URI. We've got our URL right here, our protocol, domain, and our web page. And then we have this little thing right here. It's actually called an anchor link, but we've got this hashtag date. Now, this hashtag date allows us to specifically identify where a piece of information is located on a web page. We don't actually need it in order to access that information. So right here, we're talking about identification and location rather than simply access. And when we do that, we're referring to a URL, to a URI rather. If we're simply talking about access, which is this part, and this is all we need to access the particular information in question, we're talking about a URL. So anything outside of the protocol, domain, and web page, you're probably going to be working with a URI. Now, when we type URLs into into our browser, right? It's not as simple as just typing in a URL and then directly getting our web page. Remember, we access web servers and by extension web pages through the use of IP addresses. So in order to translate a URL, to go from a URL to an IP address, we need to use something called domain name servers, or a domain name server. And let me walk you through what that means. So when you type a URL into your web browser, it gets sent to a domain name server first. And this domain name server is just a server that's generally associated with your ISP, meaning your internet service provider. Now, just to clarify, when we're talking about an internet service provider, we're talking about Comcast, we're talking about whatever company through which you get your internet. Now, when you do that, the domain name server checks if a URL exists in its list of URLs, and if so, it returns the corresponding IP address. So a domain name server basically contains a database or a table in which there are URLs on one side and IP addresses on the other side. So it functions like kind of a phone book where you've got URLs and you've got IP addresses. So if the URL you typed in exists on that particular domain name server, then it returns the IP address to you, or specifically your web browser, and then your web browser automatically sends a request using that IP address. If not, it passes your request, it passes your URL along to other DNS servers that it is connected to in a hierarchy. And it keeps doing that, keeps bouncing them in between DNS servers until you get a match from that URL to an IP address, at which point the IP address is sent back to the first DNS server you tried to access. And then from that DNS server, it's sent to your web browser so that you can finally access that web page. So to kind of like recap, basically what happens, you type in a URL, it gets sent to a DNS server. That DNS server tries to find an IP address that matches the URL. If not, it sends it to a bunch of other DNS servers until there's a match for your URL. And then that IP address is sent back to the first DNS server you tried to access, which then passes it on to your web browser, which you then use to access a website. So right here, our DNS request, maybe you want to access sectigo.com, so we sent that to a DNS server. The DNS server sends back a response with the IP address, and then your browser uses that IP address to connect to sectigo.com's web server. Now, to kind of go into detail in the into what like a DNS hierarchy is and like what this whole DNS concept is. So DNS servers are basically scattered across the globe, and they're a common resource managed by global non-governmental organizations. So kind of the standards are set for how these are supposed to work, for how DNS servers are supposed to work, and the rules that govern DNS servers are set by global non-governmental organizations whose job is to sort of manage the internet. And everyone on the internet, everyone who works with the internet kind of accepts that these are the people who are going to make these decisions. Now, while the rules for how DNS servers are supposed to work and how the DNS hierarchy works is set by these organizations, the DNS servers themselves are operated and managed by ISPs, like Comcast or whatever other awful internet service provider you have, or domain name registrars like GoDaddy. Now, there's no fixed number of DNS servers globally, but it is a massive network of servers, and there are clusters scattered across the globe, as we can see from this little picture right here. Now, the next concept we're going to talk about is HTTP, or Hypertext Transfer Protocol. Now, we referred to this a lot in previous slides. HTTP is obviously a protocol used to make requests across the internet. So, for example, if we are an HTTP client, so this is us, on our web browser, we want to access google.com. The way we're going to get access to Google servers and get that web page at google.com is going to be through sending an HTTP request and receiving an HTTP reply in return or response. Now, this is the main protocol for transmitting information on the World Wide Web. So anytime you request a web page, you're using HTTP. And it's important to remember that for other functionality, for example, instant messaging or file transfer or emails, you're not using HTTP. So this is specifically for viewing web pages. Now, what HTTP dictates is that information that is sent to a server using an IP address must be written and stored in a very specific way, following the rules of HTTP. So it's a way in which we transmit and receive information. So basically how HTTP is going to function is that we're going to send an HTTP request to a particular server. And basically we're going to say we want to send this request to this URL. I mean, obviously the first thing we're going to do is that when we send a request to that URL, we're really going to be sending a message to a DNS server, which is going to return us the IP address. And then that HTTP request is going to be sent with that IP address to a given server. Now, if we're talking again about google.com or facebook.com, we're really sending it to one IP address. But behind that IP address, there are hundreds of thousands of or millions of computers that will basically deal with incoming requests and return a response. So when we do send our request to google.com, and there may be some input, there may be a search query or something associated with that, we're going to receive a response from google.com that's going to include HTML, CSS, and JavaScript files, all of which can be described in our web browser. So then we'll have some cool stuff and whatever. So particularly in working with web science in this topic, we're talking about sending an HTTP request with some data, and then we're receiving an HTTP response in the form of HTML, CSS, and JavaScript, which are all file types that can be displayed in our web browser as what we refer to as a web page. Now, what I want to do is I want to go more in depth into this whole process of sending a request and receiving a response, because it's kind of fundamental to understanding how things work, not just in terms of this topic, but later on we talk about PHP and actually like doing some basic web application development. So the first thing that's going to happen is DNS resolution. And this is basically when we send a URL to a DNS server and we get our IP address. Now, once we get the IP address of the server, then we're going to use the TCP protocol to establish a connection with the server. Once we've established this TCP connection, remember TCP is coming from the TCP IP we talked about. Once we've established this connection, which you can think of as sort of a pipeline, through that pipeline, we're going to send a request using our HTTP protocol. I guess P is protocol, but we're going to send HTTP requests through that pipeline formed by TCP. Once you've done that, the server will receive it and then process it. The way it processes it varies from website to website, depending on what kind of information needs to be returned in response to that request. Now, once we've processed the request, and we're going to generate an HTTP response. So a response in the format of an HTTP message that follows the protocol. Now, that TCP connection we established initially is still intact, and we're going to send our response back with HTML, CSS, or JavaScript, or JavaScript over through that same TCP connection. Then the client, which is as on a web browser, we're going to receive that response, that HTML, CSS, and JavaScript, and render it or show it in our web browser in the form of our website with our text and our input boxes and whatever. And once we've displayed and rendered that response in our web browser, the TCP connection is closed. So yeah, right here, this is us. And whenever we're talking about the web browser or the user, we're going to refer to the client side. We are the client. And the server, the google.com or the facebook.com or whatever that we want to access, that's going to be the server side. So we're sending our request to a web server. The web server holds some files. So technically, this is actually part of the web server. The web server processes our request, and then it's going to return HTML, CSS, and JavaScript in a response. And then we see that on our browser. Now, what we're going to get into here really soon is something called server-side scripting. Well, the idea of client-side and server-side scripting, more specifically with web applications. Now, if we really get into the nitty-gritty of how web applications work under the hood, so generally what's going to happen, we're going to send an HTTP request with parameters. In the case of google.com, that might be a search term. That's going to be processed on our server. And on our server, we're going to have some code. We're going to have a program written in a language like PHP, C#, or something like that. And that's going to be taking our HTTP request and processing it, and then deciding what to return, deciding what HTML, CSS, and JavaScript to return. In many cases, this PHP or whatever code that lives in the server will determine what HTML, CSS, and JavaScript to return in response. Now, when we're talking about the code that sits on the server that's deciding what response to send back, that's going to be a server-side script. Now, the HTML, CSS, and JavaScript is referred to as our client-side script. And we'll get back to that a bit later. Now, the next thing we're going to talk about is Hypertext Transfer Protocol Secure. Now, this is essentially a secure version of HTTP, and it's almost universally used nowadays. In fact, if you try to go to a website that does not make use of HTTPS, then it might not even let you do it in Chrome. Now, HTTPS includes encryption of your data that's being sent and received over HTTP using either the Secure Socket Layer standard or the more advanced and Secure Transport Layer security standard. It also uses something called a digital certificate. Now, a digital certificate is something that a website needs to apply for from an independent organization called a certificate authority. And this digital certificate basically verifies that that website is secure and that it is trustworthy. They'll basically test the website to make sure that everything works as it should. And when you decide to connect to that website over HTTP or over HTTPS, before any information is transmitted, your web browser, meaning Google Chrome, will check to make sure that will actually verify that digital certificate to make sure that the website you're accessing is indeed trustworthy. So with SSL certificates specifically, the user is entering in an HTTPS address, which is identified by this HTTPS at the beginning of your URL. Now then the server shares its SSL certificate and a public key. Your browser verifies the SSL certificate. Then your browser sends encrypted data using SSL or TLS and the secret key. You don't really need to know about the secret key and the public key, but that's part of it. The server decrypts the data and receives the secret key, And then the web browser and server share encrypted data using this key that was sent. Now, the public key and the secret key are part of the encryption scheme using SSL or TLS. But I really just had this right here in order to illustrate how digital certificates or SSL certificates worked. Or I guess we could also say TLS certificates in general, because they have the same methodology. Now, one thing I do want to point out, and I want to emphasize, is that anytime we have a URL that looks like this, or not like that, we got to have HTTPS. That means we are using HTTPS, and therefore we are operating in a secure context. We just have HTTP, then we are not using we're not using encryption, we're not using a digital certificate. Now let's go through an HTTP request cycle, which is very similar to an HTTP request cycle, but I just wanted to go through the whole process again with HTTPS differences, or the HTTPS process included, so you guys can see what the differences are. So obviously, just to start out, in the beginning of our request, just like in HTTP, we are doing DNS resolution. So we're sending our URL to the DNS server and getting an IP address. Once we get that IP address, we're going to establish a connection over TCP. And this connection, so we're going to, on top of this TCP connection, we're going to be using TLS or SSL. And so we're setting up like basically a pipe between our browser and a web server. And this is established by TCP, but an additional pipe is established inside our TCP connection to ensure security and to manage encryption. And this additional pipe is defined by TLS or SSL protocols. Now, basically the way that this works is when we're establishing this connection, the client and server perform what's called a handshake to negotiate the encryption algorithms and exchange keys that will be used to secure communication between them. So basically talking to each other and saying, okay, this is how we're going to encrypt the information between both of our servers, and yeah, just basically communicating with each other. The server is also sending its digital certificate to the client, to the browser, and so in this handshake phase, your browser is verifying the digital certificate to make sure that we are communicating with a legit website. And this certificate verification process is something we've already gone over, but we're going to be checking the certificate chain, verifying the digital signature on the certificate. So every certificate has what's called a digital signature to verify its authenticity, and making sure that the certificate is still valid. You don't need to know too much about this, but it's just there for your information. And then once we have verified the server's digital certificate, we're going to send an HTTP request, a usual HTTP request, over our pipe to this encrypted pipeline. After that, everything kind of functions the same. When we terminate our connection, we're going to be closing that SSL or TLS pipeline as well. So right here, this is a very basic graph. So this represents HTTP, which is an insecure connection, and this represents HTTPS, which is an encrypted connection. So basically, the idea is if a hacker tries to intercept the data being transmitted from your browser to another server, in HTTP, they might be able to see it. In HTTPS, they will not be able to see it because they don't have the key to be able to decrypt whatever information is being sent. Okay, so the next concept we're going to talk about is going to be ports. Now, if you've ever seen something like this, we have google.com, and then you have a colon followed by a number like 80. You may have come across this if you've ever done any web development or anything like that. This number is referred to as a port. Now, ports are used so that a client and a server can communicate in the context of a specific process or service. Actually, in reality, whenever you are accessing a website, whenever you're accessing a website over HTTP, you're always using port 80. You just don't see it. Because it's kind of like, I think it's kind of just taken away, or it's kind of not displayed by default because it's so common and doesn't really serve any purpose for the average user, but it's there. So ports are identified by numbers ranging from 0 to 65,535. And as I said, each number is associated with a specific protocol or service. Again, you may not see the port number, but it's there. So for HTTP, it's port 80, for example. For HTTPS, it's port 443. And for other protocols like SMTP and FTP, they have their own port numbers. Now, this allows multiple network services to run simultaneously on a device. So that means that a server can be receiving emails or can be receiving files and can be receiving HTTP requests at the same time because they're each happening on different ports. So you may or may not see it. I mean, I have seen questions about ports. So this is just so you know what it is or don't get thrown off when you see a colon followed by a number after a URL. Now, just to kind of illustrate this again in a different way, here we have Jill's PC. Now, Jill is sending a request from her outbound port to port 80 on a server, which corresponds to the web server, which means she wants to view website. Now, Jack may be trying to connect to the same web server, but he wants to get a file from the web server using FTP. So he's sending a request to port 21 on the web server to then get a file over the FTP using the FTP protocol. This is using the HTTP protocol, and this one's using the FTP protocol. But they're communicating with the same server, just over different ports that are listening for requests from clients. Now, perhaps I should have gone through this earlier. I guess I kind of took it for granted that everyone knew what a web browser was. Especially for some of you where English may not be your first language, maybe it just, I don't know, maybe it wasn't so clear. Anyways. Basically, what a web browser is a software application that is used to access and display content on the World Wide Web. We're specifically talking about web pages. You can also download files through a web browser and interact with web-based applications. Now, when we're viewing web pages on a web browser, those web pages are typically composed of HTML, CSS, and JavaScript. Additional functionality that we can access in our web browser includes the ability to manage bookmarks, keep track of history, and change our preferences. And when we're communicating in our web browser, we're utilizing the HTTP or HTTPS protocols. Some examples of web browsers include Google Chrome, Safari, and Mozilla Firefox. And if you've not used one of these three, I don't know what to say. Now, another kind of tiny concept here is cookies. So cookies are frequently used when you access a website to keep track of how you interact with that website. If you're in the EU, you pretty much always get this message at the bottom of your screen that asks you to accept or reject the website's request to use cookies. Now, cookies are basically just small text files that are stored on a user's computer, specifically in the web browser. So when you visit a website, it'll store that text file in your browser. And this is so that the website can remember your user preferences, your login information, any other data that corresponds to your activity on that website. Each cookie is actually denoted or identified by a unique code. And the website will probably have its own database that keeps track of the codes and the users that correspond to those codes. So the client's IP addresses that correspond to those codes. This means that on the website, when you access a website, it'll see the cookie in your web browser, and then it can pull up some data. Well, it'll see the cookie with the data in your web browser, and then just use that cookie to display personalized information, or it might use whatever is stored in that cookie, it might take that information, store it in its own database to keep track of your historical data. So the point being that every cookie is a small text file, keep tracks of your activity on a website or even on other websites, and has a unique identifier that the website will use to be able to access that cookie and then deliver personalized content to you accordingly. Now, basically, the way that works is a website sends a cookie to the user's browser. The cookie is stored on the user's computer. The website uses the cookie to keep track of user preferences, such as language settings, font size, or display options. And then the website uses the identifier or the code of that cookie on subsequent visits to serve content to the user that is personalized. Now, some of the user implications, particularly with regards to privacy, can be the fact that cookies can actually track your user behavior across multiple websites. Then when you access their website, they can take that cookie and use that information, or they can actually just store it on their database as well. And then once they have this information, it can lead to them delivering you targeted advertising based on your usage habits. And this can lead to privacy concerns, particularly when we get to cookies tracking your behavior, not only on the website from which the cookie originated, but across multiple websites. So now what we're going to do is we're going to get started with basically how web applications work and web application development, beginning with some HTML. Now, like I said, this is probably the most complex aspect of the SL exam. And in a way, I just don't understand why they did it. It's kind of overkill to ask students to combine a bunch of different concepts, including databases, markup, etc., and basically to have you actually be able to read and understand web applications using PHP, and just a bunch of languages. Anyways, without further ado, so HTML refers to the hypertext markup language. So it's used to create web pages and other types of documents that are intended for display in a web browser. I mean, a web browser is basically built to display HTML, among other things. So basically what happens is we have a web page right here, and underlying this web page is HTML code that tells the web browser to display this picture and this text in the format in which it is displayed. So HTML is used to structure content in web pages and provides a way to add text, images, multimedia links, and other types of content. It's based on a set of tags. By tags, we mean something that looks like this. It has, what is this, an open, I don't even know what this is called. That has these two arrow things on either side. I really, really wish I knew what to call that right now. I guess we'll just call it a bracket. Okay. Anyways, these tags are used to indicate how content is displayed, such as headings, paragraphs, lists, tables, forms, etc. And oftentimes, actually almost all times now, when we're looking at modern websites, HTML is used in conjunction with CSS and JavaScript, which are two other types of languages, which are stored in their own respective documents or which are included in HTML pages. And these help add both visual styling for CSS and interactivity for JavaScript to HTML pages. So basically, HTML, CSS, and JavaScript are all going to be working together in modern web pages. And it is the responsibility of the web browser to interpret HTML, CSS, and JavaScript code to display websites appropriately. Now, HTML, CSS, and JavaScript are all code, and this code is an example of client-side scripting. Now, there are kind of varying definitions for client-side scripting. Some just refer to HTML, CSS, and JavaScript. Others focus specifically on JavaScript, partly because HTML and CSS are markup languages that specifically focus on how do we display information, versus JavaScript is an actual programming language with loops and ifs and control structures like if statements and functions, which HTML and CSS doesn't have. And furthermore, JavaScript can be used to actually create or add sophisticated interactivity, like this game that's played in a browser. So client-side scripting can either refer to HTML, CSS, and JavaScript, or it can refer to just JavaScript, both of which are executed on the client side. The client side meaning the browser. Now, on the other hand, server-side scripting, which we touched on earlier, is the process of using scripts or programming language to generate web pages on a server. So for example, if we go back to, I think we actually have a picture right here. So remember we had a web server and we had our client, which is our browser. So if we're sending an HTTP request to a browser or to a web server, that web server is taking a request and then using a programming language like PHP or C# or something like that to decide what response to send or what HTML or what information to send back to the web browser. That's an example of, well, that's the server side, right? And the code that handles our request and returns a response is a server-side script. So server-side scripting really refers to writing code to execute in the server that will take an HTTP request from a client, from a web browser, process it, and then return some HTML or return some content that's viewable in a web browser in return. Server-side scripts are written in languages like these: PHP, C#, Java, and Ruby, among many, many others. So just going to summarize, like how server scripting is going to work is a user is using their web browser to request a web page from a web server. When they send that request, when that request is received by a web server, some code is executed that processes that request. And this code can access data on a database. So for example, if you send a request with login information, with a login email and password, it may compare that against data on a database. And then if it matches a login or like login information on a database, you might receive the matching information in return, which might be a Facebook profile or whatnot. Anyways, the process of accessing that database, then recalling and putting that information into a way that can be displayed in a web browser is all done by server-side scripting. So some HTML, CSS, and JavaScript will be generated by that server-side script, which will be sent back to you in terms of an HTTP response, which will then be displayed in your web browser. Now, one concept you need to know, which is like, it's kind of an archaic concept, and it's basically illustrative of the fact that this curriculum was created in 2014 and still hasn't changed. Next year being the last year it'll be examined. And if you think about like 2014 to 2003, that is like an eternity in terms of web science or just computer science in general. Anyways, one concept that's illustrative of that is the Common Gateway Interface. So the idea is that a common gateway interface serves as an intermediary between basically our server and the code that's going to be processing our HTTP request. So let's say that we have a little diagram right here, okay, and we're sending an HTTP request to that server, okay? So that's our server. On that server, we have some PHP. So in between our HTTP request and our PHP, it's going to be our CGI. And our CGI is basically taking that request, that HTTP request, and handing it off to our PHP script for processing. So it's essentially an intermediary or a middleman or middlewoman, and it accepts an incoming request, and then it executes whatever script is meant to be executed. And the CGI also actually returns the result to a client. So once the PHP has done whatever processing, the CGI is also sending the response back. Okay. Now, the reason why I say this is outdated is because we don't really use like the specific separate CGIs anymore. The CGI has largely been replaced by language-specific solutions for executing code on web servers and returning the result to the user. So you do need to know what a CGI is, how it works, but in reality, it's not really used anymore, at least in this format. Like the concept exists, but just not exactly in this way anymore. So right here, just look at a diagram and kind of recap. The browser is sending our URL, sends the URL of a CGI program. Okay, so this is basically like, this is kind of leaving out the DNS part. Basically, the idea is we're sending our request to a CGI program. CGI program is using our code, which may be in PHP or something. It's taking the output from that PHP script or that server-side script. So the CGI is sending our processing and sending our request to the PHP script. PHP script is processing it, sending the response back to the CGI. The CGI is sending that response back to the browser. Now, keep in mind, again, this doesn't have to be PHP. This could be any server-side, I spelled that wrong, any server-side script. And if like the term script is unclear, script just means a program or code. Program or code, okay? I just don't want the term script to be confusing to you guys. All right, so here we are. What we're gonna do now is I'm gonna deliver you an absurdly quick crash course in HTML, PHP, and a little bit of CSS, as well as JavaScript. Now, The thing is, like, it doesn't make sense for me to turn this into like a web development tutorial. So I'm going to assume that you've already kind of run into this a bit. And this is going to be a review of how HTML works. So let's go ahead and let's get started. Okay, so let's start with the basic components of this HTML document, which is we're going to call example1.html. I'm actually going to put this like these HTML files up online so that you can actually access them on your own and kind of play around with them. But what we should know is that in an HTML document, we have a few basic components that are all defined by tags. Now, this right here, or anything that looks like this in brackets, is a tag. Okay. So for example, this is a tag that just denotes that we have an HTML document. Basically, we're going to have these HTML tags surrounding our document, and then we're going to have a head, a body, and a footer generally. Now the head goes from here to here, and we know that because whenever we have a tag like this, that means it's the end of that particular section. So we have head, which means the beginning of a section, and then we have backslash, is that backslash, front slash, backslash, head, which is the end of that section. Similarly, right here with our body, we've got body, and then we've got another tag right here. It's right down here. That's denoting the end of the body. And the footer, which goes to the bottom of the page, actually sits inside the body, which sometimes happens. But with that as well, we've got a footer and then we've got a backslash. Now, what you should know about the head is the head generally contains information about a web page. So that could be the title, which appears in your tag. That could be metadata, which tells the search engine what's on the page. You might also have other tags like link. You might have something that looks like this, which allows us to access JavaScript and CSS to the top of our web page. So all of that's going to be included in our head. So to conclude, I mean, basically the head is at the top of our HTML page usually, and includes information about the web page and any other types of documents or code like CSS or JavaScript that will enhance the HTML as it's displayed. Now, the next component, so we'll just give that number 1 right there. Now, our next component is the body, which generally contains all the information on the HTML page. So right here, this is what our HTML page is going to look like. And this is all in the body, all right? So right here, we've got a header, which should not be confused with the head. The header right here is this part right here, okay? Now the H1 makes the text bigger and bold. Notice even with the H1, we have this tag right here, and then we have the backslash right here to show that's the end of that particular title. Now all of these different tags can do different things. Some of them are organizational, like head. Well, head is actually not organizational, but like body, and then main, and then footer. Others give our text distinct behavior or make them look a certain way, like H1. So we've got our header right here, then we have our main, which is kind of our main text. And there we have a paragraph with paragraph tags. And that's what we see right here. This is my first web page. I'm so excited. And then we also have a footer, which is what you typically see at the bottom of a web page. And that also contains text in the form of a paragraph. And that's what we're going to see right here. This is a really small, really simple web page. That's basically how it works, and those are the components of a web page in HTML. Now that we've kind of looked just a really simple HTML page where we just display text, let's get into some slightly more complex HTML pages, kind of like what you're going to see on your exam. Now in HTML, we can also display forms. And so I'm going to go through an HTML page that has a form on it. Now right here, we're starting out with our HTML tags, which are fairly typical. Then we've got our head, which includes at the very least the title, which you'll see in the tab in your web browser. Again, this is just information about the website. We've got a header, our H1, inside our body. That's going to be this one right here. And then we have a form tag. It's opening and closing. And everything that's related to our form is going to live inside, in between those form tags. Now I'm going to go through basically every single line of this and how it corresponds to the form. So the first thing we have is a label, which corresponds to this right here, and we have the text of our label. And the for equals name means that it corresponds to the input with the name, which is this name, which is confusing. Now this input right here corresponds to the actual white form, so that's going to be this right here. The BR means that the next label and form is going to go on the next line. So that's what BR is, next line. So right here, to go back to this input, we've specified the type as text. We can have different types. We can have numbers, email, lots of different stuff. The ID is name, which will help in styling with CSS. And the name is just going to be name. And this is going to help when we start passing form data onto our server. Now, next we have a label for email, which is going to be our email input. So this line this particular line code corresponds to this. And then we're going to have another input, another form area, which is this. And its type equals email. So basically what's going to happen is if you type in something without an @ symbol, or it doesn't follow the format of an email, then that means that you're going to get an error message and you're not going to be able to submit the form. And then finally we have input type equals submit right here with the value equals submit. And that corresponds to the submit button, which allows us to click on the form and submit it. We'll get to that whole submission action a bit later on, but that refers to the button, and the value refers to the text of the button. So if you wrote value equals enter, then the text here would just be enter instead. And that is a basic form. Now, what you're going to have to be able to do on the exam is, you're going to have questions where you need to basically draw the form, or at least describe what the form is going to look like and what the different elements of the form are. So you do need to be able to look at HTML and understand what is being displayed. Now here's another slightly more complicated example. So what we've got here is a dropdown. So it's basically the same as the last form, except with a dropdown where you can select a variety of different options like so. So again, we've got our head, we've got our body, and we've created this form right here. These all correspond to what we saw in our last slide. So that's going to be this part right here. And then we have our label and our dropdown. So I'm going to go through this line by line. This is something you're going to see on the exam. We've got label for equals age, and that's right here. And right here we've got name equals age, which is how we know that this label is corresponding to this element right here, our dropdown. So to create a dropdown, we need to use a select tag. Okay. So we're going to have a select tag. And then inside select, we're going to have all the various options we can select from the dropdown. So this select leads to us just being able to see a dropdown. Then all these various options with their value and then the text that should be displayed, that's all going to be what we see right here. So each one of these, this is going to correspond to this, 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 and this. Now, 18. So this one right here is what we see in the dropdown. And this is what we're actually going to submit when we click the submit button and submit our form. And this whole submission aspect will make a lot more sense in the next couple of slides when we talk about actually submitting to a server. But so this one right here is this cosmetic. This is what we see. This is what we actually submit. And obviously we have our input button right down here. Now, this whole select option structure is something you need to be aware of because there have been a number of examples in the Option C exam where you've had to interpret and understand how a dropdown works. But it's not really going to get much more complicated than this. Now, this shouldn't be so small because PHP is actually really important. My bad. But so basically what we're going to do is we're going to get into how server-side scripting works, and we're going to be looking at some examples in which we're actually submitting data from an HTML document into a server-side script in the form of PHP. Now, PHP looks like this at a very basic level. We're opening with this and closing with this, and then variables start with a $sign generally, like I++. We can print stuff using the echo keyword. I'll go more into depth into this later on, but it is kind of a travesty that you basically kind of have to learn PHP to succeed on these questions. Now we can include PHP on an HTML code that sits in our server. Generally the case is we're just going to be dealing with separate PHP documents that sit in our server that receive requests from HTML and process them, or receive HTTP requests and process them. As we know, when we talked about PHP scripting or server-side scripting before, we can generate dynamic, so ever-changing content. We can interact with databases, and we can perform a wide range of tasks using PHP and server-side scripting in general. Now, we will be using PHP in conjunction with a database management system, or essentially a program called mySQL that allows us to create and manipulate a database. Again, this overlaps really heavily on option A, which should not be the case. I think it's a travesty. You basically have to learn how this works just for this one option, but it's the way it is. So mySQL, again, is a software program that can create and manipulate a database, but we will be writing code in PHP to interact with that database that will look something like this. So we'll be inputting queries, and we'll be just interacting with that program, the mySQL program in general, through PHP using PHP code. So basically the way that PHP and mySQL work together, so PHP with mySQL, is that PHP is written to access and manipulate data stored in a mySQL database. So when a user requests a web page that requires data from the database, we're executing the PHP script. PHP script is connecting to the mySQL database, retrieving or storing the necessary data, and then generating HTML code that makes use of that data and sends it back to the client's browser for display. So within PHP, where we are accessing our mySQL database, either storing or retrieving some data, and then passing the result on in the form of HTML back to our client or our server. Again, I just don't think I'm not going to go through PHP and MySQL development in totality for this exam, but I'm going to go through a bunch of examples. Again, this is my brute force teaching approach where I just give you a bunch of exam-based examples, and then I just hope that you get it. Here's a first example. So here we might have an example called, let's just say example 2.html. So this is sitting on our client. This code right here is sitting on our client. Right here, we might have some code called main.php. And this right here is going to be sitting on our server. So our facebook.com or our, I don't know, whatever your website is. Okay. And basically, we're passing data from our client to our server and then vice versa. So right here, if we just kind of break down, this is a part of a PHP document. We're mainly looking at the form this is a part of an HTML document, mainly looking at the form in our HTML document. Now, what I want you to pay attention to is that we have a label and we have a text input where we're submitting a name. This is actually the same as our previous examples. And we have another input, which is an email, which also has a name of email. We've got a drop-down with all of our different ages. So the same code as before, but we're going to be submitting it to a PHP document. Now, I'm going to have you pay attention to a few aspects. First of all, in our form tag, we have some additional attributes. The first is action, which equals main.php. Now, this is the name of the actual PHP document that we're going to be accessing and making use of. Then we have method, which is post. Now, post is kind of the format in which we're going to be transmitting data. If we use get, this means that when you access main.php, because eventually what your document is going to be doing, or what your document's going to be doing is in the browser, or it's going to be accessing the, www.google.com/main.php. That's what's happening when you submit this form. Okay. We've only included main.php, but this is really just half the story, and I don't want to go too much into it because I just want you to have minimal amount of information you can do to successfully complete the exam. Anyways, we're accessing main.php, which is actually a website address. Okay. And the method we're doing that is through post. If we used get, we would actually see all the data, like the name that we've typed in, the email that we've typed in, the dropdown we've selected in our URL. And we'd actually be able to see that in the browser if we use something called get. With post, all that's hidden, we're just seeing this address right here to main.php, and the information is kind of hidden. You don't need to know that aspect, but you need to know that there's a method called post, and there's an action, which is the name or the URL of the PHP document that we're accessing. So post and main.php. The other thing I want you to pay attention to is on all the inputs, including actually we've got our select right here. We have a name. So right here we have name equals email, and then name equals age. In our PHP document, knowing that we're using the post method, this corresponds to this line right here. We have post and then this name. This corresponds to this line right here. We have post email, which is this name right here. And then for our dropdown, we have name equals age. That corresponds to this right here. So this is basically how we're getting information from our form into a PHP document so it can then be processed. And once we do that, we're storing them in variables, which is the name variable, the email variable, and the age variable. And all this PHP script is doing is it's taking our data and then it's returning it to us in the form of HTML, the name, the email, and the age that we actually just selected. And the echo statements are basically printing out or sending that data back to our browser. So this HTML is what we would see in our browser after hitting the submit button. So we've got our HTML. Whatever is denoted in name, those fields we're submitting to our PHP, and our PHP is returning as a response. The reason we have post right here is because we've specified a method of post, and the action is the name or path of the document of the PHP that's being used to process whatever HTML that we're submitting, whatever data that we're submitting when we click the submit button. Okay, so right here, we're actually taking the data from the previous form, and we're inserting it into a database. Now, what you should know about databases is every database is made up of tables. Tables look kind of like an Excel table, okay? In our current database, the name of the database is my database. Remember, a database is just a way to store information. So we have my database, and inside of my database, we have a table called my table. And this is a table with 3 headings, one for name. So we're going to have name, email, and city. And basically what we want to do is we want to take the name, email, and city we got from our form and insert them into this table as an entry, as a row. So right here, we're getting our basic information that we need to connect to a database, which is the host, which is just the address of the database, the name of the database, the username, and the password to actually be able to access the database. And we use those variables to build a connection object right here. So we have new MySQL I, followed by all of these different values as our input. We're actually creating a connection, and then we're connecting to the database here itself, and we're handling any error that might take place. After we've done that, we're getting the form data from our previous form, and then we're building a query. A query is just a set of instructions to interact with the database. So this is our query right here. We're saying insert into my table. We're specifically inserting into the columns name, email, and city in my table. And in each of those columns respectively, we're putting the name variable, the email variable, and the city variable, which right here correspond to what we input into our form. So basically, we're creating this query to input our data as a record, like so, to input the name, email, and city all in one row into this table called my table. Here, we're going to execute that query on this line. So we're sending the query that we created in a string right here to our database via our connection object. And we're going to actually execute those instructions. And if we successfully executed them, we will return to the user using echo a message that says new record created successfully. So you would see this in your browser. Otherwise, you would see error, the query itself, and then whatever error took place. And then this connection that we've created to the database right here, we're going to close right here. Okay. So that's basically how we're going to deal with MySQL and deal with databases in our PHP code. Now, In my study guide, I'm actually going to include a cheat sheet, so you understand what all of these commands mean and you have a handy reference both in PHP and SQL. Additionally, I would say if you really don't understand this and want to know more about databases, just watch the first 30 minutes of my option D tutorial, because I fully explained this there, because that entire, sorry, not option D, my option A tutorial. Because in the first 30 minutes of my option A tutorial, I fully explain how databases work, because option A is just all about databases. Now let's look at another example involving PHP and databases. So we've got a PHP document right here. These are our variables we're going to use to actually access the database. We're building our connection object right here. We're connecting right here. And we're creating a different kind of query. This is select star from my table. So we've got my table and we've got some basic columns. So where we had name, I think it was email, and I want to say city. Okay. And we have different records. So we have different rows in that particular table in our database called my database. Remember, this table is called my table. Now, what we're going to do is when we do select from, we use select to get data from a table. So if you have select star, that means we're going to get name, email, and city for every single record from my table. If we just had select name, we would simply get all of the names, everything in the names column and the name column in the table. So right here, we're just building our query, and here we're executing our query. And here we're saying if the result is greater than 0. So our data that we're getting from the database is stored in a variable called result, and that's in the form of an array. It's really more like a map, but we're just going to call it an array. It's in the form of a data structure. And right here, we're saying that if the number of rows in our result is greater than 0, then we can actually output it. If there's 0 rows, meaning there's no data in the table, we're not going to do any of this. So if that's true, we're going to output, actually output an HTML table. So we're going to echo the table tag, then echo the headings for our table. And then we're going to use a loop right here to output every row in that table. So output all of our entries. Okay. Now this whole table notation, that's an HTML table. You might see that. I'm not going to go too much into it here. Basically, we have a table and we have tr and th. Th corresponds to headers in that table. Tr corresponds to rows. And we are basically just displaying stuff in a table the same way as you see tables right here in my slideshow. Well, anyways, that's basically what's happening. Connect to create a connection object, connect to the database, get all the rows in this example from my table, and then use a loop to display them using this line right here. And again, I'm going to put all this in my cheat sheet in my study guide so you have a good idea of how that works. I'll probably have an HTML, actually now that I think about it, an HTML, SQL, and PHP cheat sheet, just to make it super easy for you guys to know what's going on. Now let's look at some actual IB examples. So right here we have an HTML document. We've got a form, okay? And that form is going to be sending our data to process.php using the post method. We have select right here, which means we have a dropdown with 3 options, spikes, trail, and endurance. And we have an input field, so just a form field with the name size, and then obviously a submit button. So identify the language used to write this code. I mean, obviously it's going to be HTML. Describe the sequence of actions carried out by the user in completing this form. Basically what they're going to do, they're going to select one of these options. They're going to type in their size and they're going to click the submit button. 3 points, boom. Next example. So right here, we've actually got a PHP document that is going to be getting some data from a form and then processing it. So what we're doing right here is we're connecting to a database called library.db. We may not have seen this exactly in the previous examples, but this is another example of how we can connect to a database. And we're connecting to a database with the name library.db. Okay. Sorry for my awful handwriting. Now, what we're actually doing right here is before we were building a query in a different line, here we're actually executing a query. And this is our query right here. Okay, so we're basically selecting from books where author equals post author. If you remember looking at our previous example, what this means is that we had a form field with a name equals author. So that's actually coming from a form. So we're looking in our books database for where we have an author, or we're looking at our books table in our library database, where we have an author equals whatever has been submitted in the form. And then when we get that result, we're going to display each and every result in the form of a table. Okay. And then we're going to close our connection at the end here. So when we say describe the processing that takes place when the form that was sent from the client is received by the web server. So remember, this PHP code is being executed on the web server. Okay. So when this data is executed, so basically the processing that's going to take place is we're going to connect to a database, and then we're going to use the author that was sent, that form field that was sent, to find all the books in our books table in our database that have an author that was submitted by the user. Now, then once we do that, we're going to display the first name and last name of that particular author right here. And we're sending that back to the user because of echo. So we're basically returning a table back to the user. So get the author, so get all the books that correspond to the author that was specified in the form. For each row, return, so for each row, basically for each book that was found with that author in the books database, return the first name and last name of that author in the form of a table. Okay, so here's another example. So right here we have a shopping basket, and we've got a fragment of PHP code. Now this is something you may not have seen before. Right here we're using a session. A session is basically like a temporary storage variable to store some data. Usually involves user login information. So right here we need to suggest the function of the fragment of code. So right here we have a user ID that's been stored as a session, presumably that's been put in at some other time. We're going to look in the user database for any data associated with that user ID. And then we're going to get that data right here. So this is our query right here. We're building a query to get any data associated with this particular session user ID. And then once we've done that, we're going to get the data associated with that, get any records associated with that, and presumably display it. So remember, sessions are a way to temporarily store data in PHP. If I'm going through these examples kind of fast, it's because I want to just give you the minimal knowledge to be able to solve these problems. But at the same time, the purpose of this tutorial is not to teach you full PHP web development. So I'm going through as much IB specific functionality as possible. Again, I'm going to include a cheat sheet in my study guide that has kind of all of this more broken down. So you can just kind of see it laid out, and you can use it as a handy guide for your exam. All right, so this is our last PHP example. I'm going to walk through what's going on right here. So right here, obviously, we're getting 2 form inputs. I haven't included all the stuff to connect to the database. This is just the PHP that involves just processing the form input. So we've got 2 form inputs. One is item and one is size. So remember, this corresponds to a form with name equals item and name equals size. In our HTML, we have a function right here, and this function is presumably taking that data. Well, we have 2 variables right here. And this has an input. This is a parameter of data. So this is presumably going to be used somewhere further down here. And I imagine this checks whether there's actually been data that's been taken from the form and inserted or not. So right here, we're actually connecting to our database. And here we have a select statement. So we're getting these values from a table called catalog DB. We're getting all of this information for the item and the size that have been specified in our form. And then once we do that, we are seeing whether there's any data that was returned. If there wasn't, we're sending this message back to the user into their browser. Otherwise, we're getting all of the items or all of the information, all of the rows that match up to this information, this data that was entered right here. And I think this was actually for shoes. So we would just be getting all of the information for shoes that match that item ID probably and the size. And then once we've done that, we're just going to go ahead and close our connection. So yeah, that's like my really like short tutorial on PHP, MySQL, and HTML. Like coming to this, you really need to have a teacher. You need to have some like real background knowledge on how this works. But hopefully this is like an exam specific crash course. Now the next thing I want to look at is CSS. So CSS will be linked in your HTML. It's used to style and format HTML documents, so to alter the layout, font, and color. And one of the cool things is you can write CSS code and store it into files called like main.css. Okay. And then you can share that CSS between different HTML documents. For example, if you have a large web page, if you have a large website with many web pages, and then they can all share that same visual styling. Now this right here is an example of CSS. We're altering the font, changing the font size, changing the color, adding some text decoration. And our CSS document is organized by our HTML elements. So remember how we had H1? H1 was like a header in an HTML document, or we had H2 that was like a header or body. So this is altering the different sections of our HTML document. So these correspond to our sections, to our tags, and these are specifically how we want to style them. Okay, so the next concept we're going to go over is JavaScript. Now, JavaScript is different from HTML and CSS in that it's a high-level, interpreted by the browser programming language. And we use this mainly to create interactive effects like this one. So generally, we're going to use HTML, CSS, and JavaScript in conjunction. JavaScript is going to be used for the interactivity. So for example, a pop-up or a game that you see, or anything that happens in real time without you reloading the browser is probably, or any changes that happen in real time are probably going to be through JavaScript. It is a client-side scripting language, and as we said before, it's run in the web browser rather than the server, which means that you can do things a little bit more quickly because you don't have to wait for a response from a server. Now we're going to look really quickly at an example of an IB question in JavaScript. These are very rare, but I'm going to try to break this down. Again, my intention is not to teach you JavaScript in this particular video. It's just to view it from an exam perspective. So right here, got a typical HTML document. We've got a body, and then we have a script tag. So script tags are generally used to, we can either have separate JavaScript documents like how we did with CSS, or we can have them included in the HTML. If we have script tags, that means we've got JavaScript inside of our HTML. So right here we have a function called setVar, okay? And basically the way this is working is if we go down right here, we have an input form field and we have a button. And we have an on-click event. So when we click this button, we're going to execute the setVar function, which is right up here. Now, when we do that, we're going to go to the ID kippers. This is the ID kippers right here. We have ID equals kippers, okay? And we're going to get the value from there and then store it into the subject variable. So whatever the user's typed into this input field that's identified by the ID kippers, we're going to get the value, and then we're going to store that in a variable subject. Then what we're going to do is we're going to go to the element with ID subj, which is this one right here. And span just means a section of text. So we've got a paragraph tag. We're in the middle of a paragraph, and span is specifying some text that would go in the middle. And we're going to go to that ID, and we're going to set the inner HTML equal to subject. So we're basically going to insert whatever was in the subject variable right in here. Okay. So we're getting what's at ID kippers. We're storing that in the subject variable, and then we're putting that where the ID subj is, where that element with the ID subj is. So right here, for example, to describe the processing that takes place where the user inputs pa into the text box and uses the click me button, we would go right here. We'd have something like welcome to the pa department, or faculty rather, okay? State the output of the index.html file. I mean, for that one, we would just see an input right here, and we would see a button. We're not going to actually see the JavaScript. You'd also see the header and this text right here, actually. So we're just going to see whatever HTML is there. We're not going to see the JavaScript. That's going to be in the script tag and hidden away, waiting to be executed. It's a really quick example of how JavaScript is used. Again, my intention is not to teach JavaScript because that would take me an extra hour here, but I just wanted to go through HTML, CSS, PHP, MySQL, JavaScript from an exam-based perspective. So now what I want to go through is the difference between static and dynamic web pages, because that's kind of the culmination of our investigation into particularly JavaScript and CSS. Now, examples of static web pages are like brochure websites or small business websites. So we're just talking about text, very little activity. Examples of dynamic web pages are going to be social media websites like Instagram, e-commerce websites like Amazon. In reality, almost all websites that we use nowadays are dynamic websites. Now, the big difference is that static websites, you don't really see any changing content, versus with dynamic websites, you see frequent changes on your web page without having to refresh it. So that may be like images popping up, or that might be being able to play a game inside your web browser, just kind of being able to click on a button and instantly get some information back from a server. That's an example of a dynamic web page. So we're going to have a high level of interactivity. It's going to take longer to load because we're going to use a lot of JavaScript and CSS, and those files need to be transmitted from our server, and they take time. We're not really going to be making use of server-side processing like our PHP scripts with static websites, but generally we are with dynamic websites. And we're going to be using a lot of JavaScript and something like Ajax, which allows us to get data, send data, and get data from a server in real time without refreshing our page. Ultimately, a dynamic web page just has a lot more interactivity and just frequently changes. So those are some of the big differences between static and dynamic web pages. The point of JavaScript is to give us dynamic web pages, and to an extent CSS as well. Now the next thing we're going to talk about is XML, called the Extensible Markup Language. So basically what XML is it's used for encoding data in a format that is structured and both human and machine readable. So when we use XML, there's a variety of cases. It may be transmitting data between software applications. One of the most frequent cases in which you use XML is transmitting data between a server and client. So we don't always, whenever we are communicating with a server or with a client, whenever we're communicating with a server from our web browser, our applications aren't always going to send a request and get full HTML and CSS back. Sometimes we just want to send data to a server. So maybe, for example, if we want to update the server on our current status, or whatever it is, if we have a dynamic web application, we're constantly sending data back to our server. And a good example may be a game, an online game that we're playing. If we're just sending data to that server, then we might format it in terms of XML. Now, as you see, XML is going to be we basically have tags like in HTML, but that is to organize data. So maybe we want to send a bunch of colors. We're going to have a colors tag and then color 1, 2, 3, 4, 5. Maybe you want to send data on fruits. We're going to have a fruits tag and then fruits 1, 2, 3, 4. We can pretty much define XML however we want with whatever tags we want. But the point is that it's organized. And so beyond transmitting data between software applications and between a server and client, we may also use it just to store configuration data on an application on our computer, or especially in Android apps. If you've ever developed Android apps, XML files just sit in your app, and we use those to configure the application, to configure particularly the appearance of your application. So the bottom line is that XML is used so that we can write data that is structured and is readable both by humans and machines. Now, here's an example of an IB question involving XML. So this is a snippet of XML that contains details of a DVD collection. Identify the error in the section of XML code shown above. Now remember that XML is largely structured in a similar way to HTML because they're both markup languages. So right here we had opening and closing tags, right? We had colors, and we had colors the backslash as well. And then we had different colors within, so we had different elements within a larger element, this being the larger element, these being smaller elements. So right here, if you look right here, it says identify the error. So we've got collection, that opens and closes right here. And we have DVD, and that opens, and that's supposed to close right here, right? So every DVD, so if we have the information for one DVD right here, we should have DVD, so we should have that. And then we should open up another one for a new DVD. Similar to right here, we had color 1, and then we had color 1 with the backslash. And then we have the same thing right here. So the lack of closing tags with a backslash and opening tags for the second DVD is the error. Now, something else you might run into is XHTML. This combines both XML and HTML, so it can be both processed by XML tools or applications that make use of XML and displayed in the browser as HTML. This can be used in data-heavy applications so that we can easily display data and transfer data in the same document. It's just a lot more efficient if we can not only display data in a browser that we're also sending to a machine to be read and processed. Now, XSLT, it's a language that's executed by a software program called an XSLT processor. The point of XSLT is to instruct this XSLT processor to transform our HTML or XML into HTML, XHTML, or even XML in a different format. So for example, you might want to take this XML right here and turn it into HTML. We would use XSLT for that, or maybe even turn it into XHTML, and we'd use XSLT for that as well. Now we use it for three particular purposes: displaying XML in a browser, as we just said, generating reports, because we can also use XSLT to transform XML into PDFs or Excel documents. And we can use it for system integration. So maybe we have two systems that use XML, but they're in different formats. We can use the XSLT language in conjunction with an XSLT processor to change XML from one format to another so that we can transfer data between two applications or two systems that both use XML. Okay, now let's move on to search engines, having left behind the trauma of PHP. So you guys know what a search engine is. Basically, you type in a search query, and then you receive the most relevant links to information connected to that search query. So formally, a search engine is a software program or online service that enables users to search for information on the internet by entering keywords or phrases related to their search query. Now, a key aspect of search engines is that algorithms are used to search through vast amounts of data stored on web servers to present the most relevant results to the users. The algorithms will be a focus of the option C content. Now, examples of search engines are Google, Bing, DuckDuckGo, etc. Unless you've been living under a rock somewhere, I assume you've used a search engine before. Now, we're going to talk about how search engines work. Basically, the way it works is search engines use crawlers, spiders, or bots to scan the web for content. So these are very similar things, but we're going to focus on a crawler and the process of crawling. So what crawling means is a search engine's crawler scans the web and follows links from page to page to collect content. So basically, a crawler is acting like a sort of a vacuum cleaner, just sucking up websites and content related to those websites. So that's the first step, just getting content and just storing content off the internet. So generally, we're not storing we're not storing videos or images. We're storing both metadata, so information describing those websites, and potentially content from those websites or textual content from those websites as well. This really depends on the search engine and how that particular search engine works. Now, the second thing we're going to do, and that should be number 2, is we're going to index all that content we've sucked from the web. So we're going to organize it into a searchable index, along with information about the page, such as title, URL, and other metadata. So basically collecting a bunch of content from everywhere on the web, like as many web pages as we can, and then we're organizing it so that we can easily find websites, or we can easily find content that matches the keywords that users type into a search engine. Now, next we're going to get to the actual query itself and how that works. So this is going to be number 3. So when a user enters a search query, the search engine's algorithm retrieves the most relevant pages from the index, and then ranks them based on a number of factors, including the relevance of the content, the quality of the website, the popularity of the page, and other factors. So basically, we've basically collected all of this content from all over the internet. We've organized it in a way in which it's easy to find certain information about it, like the topic, keywords that exist, etc. And then when a user enters a search query, we look through that index and we find the most relevant websites and then rank them based on a variety of factors. Now, this is where the search engine's algorithm comes to play, which is a big reason why search engines like Google have succeeded and others have not. Now, once we have actually ranked all of these sites, we return a list of results based on the user's search query, the most relevant pages appearing at the top. And then users can do what they want with those results, filtering them, or going more in depth to find exactly what they want. That's number 5. Now, search engines use complex algorithms to determine the relevance and quality of content. And they're kind of always changing these algorithms to provide better search results and to stay ahead of any attempts to manipulate search rankings. Moreover, with technologies like artificial intelligence and machine learning in general, additional tools are being used in order to find the most relevant and highest quality results for users of search engines. Now, when a search engine is ranking content, there are a couple of search engine metrics that are particularly common. And again, for some reason, the numbering on my slides is off. Not really sure why that happened this time. But anyways, the first one is going to be relevance. So that's pretty simple. So when the user types in a query, how relevant is the content, the headings, any title tags, or any metadata? The second is whether that is an authoritative source. So we're talking about the number and quality of links pointing to it. Like if you write, if a page is a pretty significant authority, so let's say the New York Times, for example, there are going to be a lot of links that are pointing to the New York Times as a source. And so we can consider that to be more authoritative. Well, not necessarily we, but a search engine may consider that to be more authoritative. The third is going to be user experience. So factors such as page load time, mobile friendliness, and ease of navigation are all going to be factors in ranking a particular page. And these would have been collected, and these factors have been collected and taken note of during the crawling process. Freshness might be another factor. How recently the page has been updated to make sure that the user gets a result that is as up to date as possible, with this being indicative of its relevance. And then finally, engagement. So how users engage with the web page, taking into account factors such as click-through rate, bounce rate, and time spent on the page. It's basically how much time users are spending on the page and how many people are visiting the page, possibly. Because oftentimes what other people are doing can be a good indicator of whether a particular page or link is relative to your user. Now, I just want to go back to meta tags. We talked about this earlier in HTML documents. But meta tags provide information about a web page to search engines and other applications that may access the page. And I just want to emphasize that this is one significant way in which search engines are able to analyze and index web pages and then decide whether they are relevant or not. Oftentimes, when you actually see a link or you see a result in Google, the text will be what is specified in the head of the HTML as being the description, the title, possibly other information. Right here, there's just the description, the title. But I know that that metadata can be used for other things as well and can be displayed in other places potentially. Here's an example. This would be metadata. So we've got the title, obviously, which would be used. There's also description and the content of the description. There are relevant keywords that can be used to help index a particular page and then recall it. There's also an author. So if someone is looking for a website or an article by a specific author, then we've got the metadata for this particular article that indicates that John Doe is the author, and that can be matched up with a user query. Notice these are all in the head, and they all have meta tags, indicating that they are metadata. Now, when we are using search engines, the content on the internet that is accessible by a search engine is called the surface web. So it includes any publicly available content viewable in web browsers. However, the majority of the content exists in the deep web, of which the dark web is a part. So the deep web refers to parts of the web not indexed by standard search engines. Now, when we mention the deep web, a lot of people think of selling organs online and buying nuclear weapons and stuff like that. That is the dark web, not necessarily the deep web. The deep web can include private networks like intranets, or just networks that are isolated from the internet, dynamically generated content, so content that's being generated in your browser by JavaScript due to some sort of interaction, non-public databases. Healthcare databases are not going to be shared online. They may be accessible online, but you're not going to be able to just access them through a search engine. Password protected pages, or even pages with no incoming links. So pages that no one else is linked to, just due to the nature of most search algorithms, could be considered part of the deep web because you can't really find them on search engines. Now, the dark web, which you should also be aware of, is a subset of the deep web. It's intentionally hidden from search engines, often requires specialized software like the Tor web browser to access. The Tor web browser ensures anonymity. And part of the reason is because typically websites in the dark web are associated with some sort of illicit activity, or at least activity for which the origin probably wouldn't want to be known. So basically, if people are using the dark web, they probably want to remain anonymous, right? Because they're probably doing something that is either controversial or for which they just wouldn't want their identity to be revealed. So what you need to know is that the dark web is part of the deep web, and it requires specialized software to access. It doesn't have to be associated with illicit activity, but more often than not, I think it is. Now moving on, we're going to talk a little bit about search engine algorithms, with PageRank and HIT being the two algorithms that are covered by option C, and perhaps the best entry point to learning about search engine algorithms. Now the first type is PageRank, which has been popularized by Google. We're going to give a really primitive description of what this is, just enough for the exam. Obviously, the real PageRank Google algorithm is proprietary and much more complicated. So basically what the PageRank algorithm does is it analyzes links between web pages to rank relevant web pages in terms of importance. So a web page is considered more credible if other pages link to it, like our New York Times example, right? Like the New York Times is probably going to be considered pretty credible because a lot of websites will link to it. Each web page is assigned a score between 0 and 1 based on quality and actually quantity of incoming links. Sorry for the typos. I did this really, really quickly. I'll explain a little bit more about that towards the end. But anyways, quality and quantity of incoming links. So just to kind of summarize, the algorithm's taking in the quantity of incoming links, so how many actual links there are to a particular website, the quality, so how authoritative those sites which are linking to your site, how authoritative they are. So for example, if the New York Times is linking to your website, then their link is going to be worth a lot more than someone's blog just linking to your site. And then the relevance of incoming links. So if there are other websites that are linking to your site that are relevant to a search term, then your website's going to be ranked higher. So a big part of the PageRank's ranking algorithm or ranking criteria is incoming links. Okay, so we've talked about inlinks. Another term is outlinks. So let's say that the page being ranked is dogs.com. Okay. And the New York Times is linking to dogs.com. Dogs.com is the one we want to rank. Now, this is an inlink for dogs.com. Now, if dogs.com links to, I don't know, pets.com, for dogs.com, that's an outlink. Now, in terms of the PageRank algorithm, outlinks don't make any relevance, or they don't make any difference for the rank, but it's still worth knowing this term. One thing you should know, though, is that the value of an inlink depends on how many outlinks there are from that page. So for example, I would say the New York Times and probably pets.com are both authoritative websites. So I would say that the New York Times and the pets.com are both authoritative websites, let's say. However, if the New York Times has 500 outlinks, so that means it links to 500 other pages, and pets.com, which is similarly authoritative, only links to 20 pages, that means that an inlink from pets.com, so if we had an inlink from pets.com, and let's just say that we don't have an outlink anymore. We just have an inlink from pets.com and we have an inlink from New York Times. This inlink would be worth more. This inlink from pets.com would be worth more than from the New York Times. Okay. So the value of an inlink in the PageRank algorithm depends on how many other websites that website that's linking to yours also links to. So maybe just to give another example, let's say we have a website called, I don't know, guns.com. Okay. And we have a popular website called Gun Enthusiasts, or to say gunenthuse.com. And we have a similarly popular website called ammo.com. Okay. And these both link to guns.com. Now, Gun Enthuse only links to 10 other websites. Okay. Versus ammo.com links to 50 other websites. Then this inlink from gunenthuse.com helps rank guns.com higher, or it helps it rank higher more than ammo.com, because there are fewer outlinks from Gun Enthuse than from ammo.com. So it's kind of a relationship between outlinks and inlinks and kind of how that factors into ranking a web page. And the next search engine algorithm we're going to get into is going to be the HITS algorithm. Okay, that is the hyperlink induced algorithm. Now, here's a few steps on how this works. Basically, first, the HITS algorithm identifies a set of web pages relevant to the user query. This is going to work similarly to the other algorithm in that it's going to make use, the search engine that uses this algorithm is going to be crawling through a bunch of websites and collecting content on them and then indexing them. And that's how this algorithm is going to identify the relevant web pages. Then it's going to give each web page an authority score based on the number and quality of incoming links or inlinks. It's also going to give each web page a hub score based on the number and quality of outgoing links, based on the pages it's linking to. So is it linking to authoritative websites of high quality or not? So yeah, unlike the PageRank algorithm, the HITS algorithm is taking outlinks from a particular website into consideration. So it's getting a score both on the number and quality of incoming links and outgoing links. With quality being judged on that particular website that's linking into the website being ranked, and the websites, and basically the websites that outgoing links from the website being ranked, and the quality of those websites that are being linked to from the website being ranked. And we're going to combine both these scores to generate a combined score, and then rank web pages based on this score. So main difference is that we're taking outgoing links into consideration with the HITS algorithm. Now let's move on to SEO, to search engine optimization. Now basically what this is the practice of optimizing websites and their content to rank higher in search engine results pages. So this is obviously super important, particularly for businesses, because the higher they are ranked, the more likely they are to catch someone's eye and to get business, or to at least get their brand out there. Now, there are 5 common techniques we use for improving SEO rankings. So basically for improving the ranking of websites in a search engine or a search engine result page. The first is keyword optimization. So that means we're using relevant keywords throughout a web page's content, including headings, meta tags, and descriptions. So this makes sure that when the user types in a query, that we make sure that, or if the user types in a query that matches our website, we make sure that that our website is displayed. The second is simply creating high quality, informative, and engaging content. And this is partly because, as we mentioned before, one of the metrics is just user engagement. So the better your content is, the more likely people are to visit it, and the more likely people are to spend more time there. The second is link building. This obviously goes back to incoming or inlinks and outlinks and the quality of those, depending on the algorithm. And then we have site structure optimization. So we're going to optimize a website structure to make it more navigable. And this might include a sitemap and an intuitive URL structure so that search engines can easily crawl into our website and index it more easily. And moreover, this also affects just the user experience in using the page itself. And next, especially nowadays, mobile optimization is a big factor because more and more people are using websites on their phones, and having a better mobile experience can again lead to more user engagement and accordingly higher rankings. And moreover, search engines themselves prioritize mobile-friendly sites in a lot of cases. Now, those were all ethical ways to increase your ranking in a search engine result page. Those were white hat SEO techniques. On the other hand, there are unethical or deceptive techniques that can be used to improve a search engine ranking, although there are consequences. These are called black hat SEO techniques. Now, right here, we've got a list of some of our white hat techniques and some of our black hat techniques. So let's look at the black hat techniques. Now, some common black hat SEO techniques are cloaking, so presenting different content or URLs to users and search engines in order to manipulate search rankings. So you might show the users one thing and a search engine something different. There are multiple ways to do this. We're not going to go into that, but this is called cloaking. So the user sees something different from the search engine. And the user is therefore most likely going to a page that isn't relevant to them. The next is keyword stuffing. And this is using excessive amounts of keywords or phrases on a page in order to manipulate search engine rankings. So for example, you may have a page about music, and Kanye West just put out a new album. So hidden, well, maybe not necessarily hidden, but in your metadata or just all throughout, you just sprinkle the words Kanye West all over, even if that website isn't really even relative to Kanye West at all, just to get a bunch of people to come to your website. That's an example of keyword stuffing, just using keywords you know will attract attention from the search engine, regardless of whether they're relative to your web page or not. A similar technique is hidden text or links. So you might have Kanye West sprinkled all throughout your web page, but it's in white font, so people can't really see it, but the search engine can see it. And so this might artificially increase your ranking in a search engine. And the final technique is link farming. This isn't the final technique. It's actually 4 examples, not 5 examples. But link farming is the process of creating artificial links to a website in order to manipulate search rankings. So you may just create a bunch of fake websites, have them linked to your page, just in order for you to increase the search ranking of one particular page. Now, these are far from the only Black Hat SEO techniques, but you don't need to know more than 3 for the option C exam. And so here are 4. Now we're going to go to kind of an unrelated concept. So we've got a few concepts. We're actually pretty close to finishing off the SL content. We've got this, and then we've got different types of computing. So one set of concepts you need to know, this is kind of moving away from search engines, is ways of describing the World Wide Web. And these are called web paradigms. So there's Web 1.0, Web 2.0, and Web 3.0. Now, Web 1.0 could be described as the internet in the 90s, right? Static web pages, HTML, CSS, and JavaScript. You're not interacting too much. You just have text and images. Web 2.0 is probably the 2000s, more dynamic websites, more user-generated content. You're using different server-side scripting languages, more interactive. There's some cloud capability and more types of content. Social media platforms like MySpace or blogs would be an example. And this is where we are today at Web 3.0. We have machine learning and artificial intelligence integrated into our web applications. Technologies like blockchain, semantic web technologies kind of fit in here. We might have more decentralized and distributed data storage, peer-to-peer applications. Basically, the state of things are today is going to be Web 3.0. And this is just another random piece of information now that we finished search engines that I'm diving into. So let's talk about the semantic web versus the traditional web. So the semantic web is, the traditional web is considered to be unstructured data with no standard way of describing it. So think about like just a news article. We have a bunch of like content, but we don't have any specific way for a machine to read and make sense of that content without AI. We've got some metadata, but we don't really have any sophisticated way to keep track of metadata. We just have what's in the head. And so when we're searching, we're just doing keyword-based searching on a limited set of content. And yeah, that's pretty much it. We just have unstructured data. Now, semantic data is a way. It's basically a way that involves XML, involves different, I would say, markup languages in order to provide additional structured data and in order to express relationships between data in a particular web page so that it can more easily be analyzed by machines. So data that is related to a web page is expressed in a machine-readable format to allow it to be easily processed and analyzed. And the semantic web is considered an extension of the World Wide Web and is also considered to be more progressive and kind of the future of the web. Okay, so now we've covered that random fact, of which there are many in option C. A rather big section is different types of computing paradigms. So the first we're going to talk about is going to be grid computing. Now, grid computing is a type of distributed computing that involves sharing computer resources across multiple networks to achieve a common goal. So this means you've got computer networks in different countries potentially that are all having their resources, including their memory, their storage, and their processing power, devoted to a common task. Different geographical locations, and they could be connected by different types of communication technologies, although most likely they're going to be connected via the internet. So you basically got different branches, if you will, different computer networks in different geographical locations, all devoting their resources, potentially being coordinated by a control node towards a singular task. And that may be something involving, I don't know, like nuclear weapons, or something that's really very computing intensive, right? So typically, grid computing is used for high-performance computing needs in government agencies, universities, or research institutions. Some type of modeling or scientific computing. Now, there's some pros or cons. So obviously, we get improved performance because we can put together the resources of a variety of networks and the machines in those networks. We have a reduced cost because if we can share resources, we don't need to buy new resources ourselves. And we can allow resources to be used on demand, allowing organizations to scale resources up and down as needed. So certain organizations or certain parts of our network can decide to go offline for some time and then come back online later. So you have sort of an in-demand capability there. The cons are because we are giving multiple networks access to our data in order to perform their task. We have somewhat of a security risk because if anyone hacks into any one of those particular networks, then they get access to what they're working on. Also, coordinating multiple networks across a large geographical area can be quite complex and error-prone. And a final con is that having such a grid computing network succeed relies on network connectivity, particularly since we're probably going to be connecting over the internet. So if we have any network connectivity issues, then we can have issues with the grid computing network as a whole. Just in terms of the fact that it may not be as effective as it would normally be. Now, the next type of computing paradigm is going to be mobile computing. So mobile computing is pretty straightforward. It involves using portable computing devices such as smartphones, tablets, and laptops. Although generally, we're going to be talking more about the use of smartphones. They can operate in battery power and are designed for use while on the move. Now, there are a few pros and cons. Some of the pros are portability. Then we've got connectivity. We can connect to networks or the internet using Wi-Fi, Bluetooth, and cellular data while they're moving around. And then cost. Mobile devices tend to be cheaper than desktop computers or laptops. Some of the cons may be limited screen size and may be difficult to do complex tasks on mobile devices. The battery life, so a computer you just plug in versus a mobile device you need to charge up. And then there may be security risks because it's easier to lose mobile devices than larger machines. And partly because mobile devices are connecting to different networks everywhere, they might be more vulnerable to hacking. The next computing paradigm is ubiquitous computing. So this is also known as pervasive computing, and this is the idea of having computers everywhere, in everyday life. So mobile devices are actually a good example of ubiquitous computing because we have them with us everywhere. But also wearable computers, smartphones where you've got sensors, and small computers or microcontrollers scattered throughout a house. And Internet of Things are all examples of ubiquitous computing. This is basically the idea of computers just being everywhere and all sorts of different devices, collecting input and giving some output. Now, some of the pros and cons are increased convenience because you've got a computer you can use anywhere for different purposes. Greater connectivity information access. You've got computers collecting data, different types of data everywhere. You can, depending on the type of computing you're using, you can easily adapt to user needs. And all of these things, ubiquitous computing, particularly if you think about something like a smart home, has the potential for improving quality of life. Now, with having computers everywhere, some of the cons are going to be privacy concerns, security risks, particularly given the fact that if all of these devices are controlled to a network, someone might just need to hack one device, like a washing machine, and they might get access to your network. And then just the cost of having computers everywhere could be quite staggering. Other cons include technology dependence, which is a moot point by now because I think we're already technology dependent, and human interaction, which again, I think we're already gone in that respect. Next, we've got P2P or peer-to-peer computing. This involves a decentralized network architecture. Computers share files with each other and communicate, acting as both a client and a server. So that means there's no central server through which computers are communicating with each other. This is a concept that was heavily covered in topic 3. Such networks are often used for sharing files and media, as well as distributed computing tasks such as scientific research and data processing. The pros are the fact that they're decentralized, provides high fault tolerance and scalability. We don't have to worry about a central server going down and taking the entire network with it. They're cost effective because, again, we don't need a central server. And there's enhanced privacy because we're only sharing information between us and any other computer we choose to. All of the information is not being stored in some central authority. The cons are lack of control and regulation, because everyone's kind of communicating on their own. There's no overarching security architecture or any protocol. And we're basically reliant on the resources of our own machines, of our own individual machines. So we don't have access to the greater amount of resources, performance benefits of having a more robust centralized system. So finally, we're at cloud computing. Cloud computing refers to the delivery of computing resources over the internet on a pay-per-use basis. So we're using remote servers to store, manage, and process data rather than relying on our own computers, our local hardware and software. We can usually access cloud services from anywhere with an internet connection using a web browser or mobile app. Now, some of the pros of cloud computing include scalability. So you're basically accessing a bunch of computers in one data center or in one network. Oftentimes, you can add additional computers, additional resources as you need. Cost savings. Oftentimes, because you don't have to purchase and maintain your own infrastructure, it can be a lot cheaper to use cloud computing than to use your own resources. And then flexibility. You can have access to your cloud computing resources anywhere from which you have an internet connection. So again, you don't need to be in one place, which makes it more convenient. Some of the cons can be downtime because you are basically using the computing resources of another company, of a third-party business that has those resources. So if those resources go down, there's not really much you can do about it. You can also have security concerns because you're not personally managing the security of your data. That third-party company is dealing with that data. So just because of the lack of control, your data might not be as secure as you'd like. And finally, if you're depending on a third-party cloud provider or you're depending on cloud computing via another service, which is pretty much the only way, or most of the time is the only reason you'd use cloud computing. If that company decides to close shop or decides to switch their policies in a way that's unfavorable for you, then you have a lot of trouble because you have a lot of data and you have a lot of investment in terms of your business into that provider. One of the most common questions I get is a difference between cloud computing and grid computing. Actually, right here, I'm going to change this right here to grid computing, and this is going to be for cloud computing. I'll just write that in a more reasonable way. Now, with grid computing, you're relying on a distributed network, so you have different networks scattered across different organizations or geographical locations. They're all working together. Versus with cloud computing, you usually just have centralized data centers that are owned and managed by a single organization. So while with grid computing, you might have multiple universities giving their computers out to complete a task. With cloud computing, you're generally working with a single organization. Additionally, with grid computing, I guess this one is sort of similar. You're sharing computing resources across multiple organizations. Yeah, these are both kind of quite similar. It's a difference between using multiple networks with multiple organizations versus single organizations. Now, I will say that one significant point of comparison is because, as we said before, you're utilizing multiple spread out networks. It's more difficult to secure because they may all have different security policies and configurations. Versus with cloud computing, you're usually using one or more centralized data centers. And this centralized nature of cloud computing means that you can enforce a single consistent security policy and therefore more easily maintain security over computing resources. Now we're going to talk about a few terms, and it's difficult to really define like sort of an umbrella theme for these. But we're going to be talking a little bit about like copyright and about different standards for maintaining network protocols or basically just maintaining the rules of the game in terms of the internet and data. The first concept we're going to go over is called interoperability. You might get a question, what is interoperability? And this is the ability of devices to work together seamlessly and be compatible with each other. So they might communicate through standardized protocols, use standardized data formats, and or have software interfaces that allow them to communicate effectively. The bottom line is if different devices are interoperable, they can work together pretty easily. They can easily share data. They can easily work together to complete a task. They are compatible with each other. Now, the next concept, standards, are very important to interoperability. And I guess these are sort of connected to our computing paradigms like grid computing or cloud computing, where we have multiple computers working together. Now, just the term standards in the context of the World Wide Web means established guidelines or specifications that determine how certain technologies or processes should operate. Now, this is kind of just so we have a set of consistent standards so that different machines can communicate with each other. Good examples of standards include TCP/IP, HTML, and CSS, and something called ISO. But like if we're focusing on TCP and IP, this is a great example of a standard because all devices know what TCP/IP is and what entails that standard, that protocol, and therefore they can communicate effectively with each other over that protocol. Same thing with web browsers and HTML and CSS. Okay, so the previous slide involved just standards. And in this slide, we're specifically going to talk about open standards. So standards in general are basically guidelines that can pertain or that can be used in any organization, right? Open standards are publicly available specifications for a specified task, and these are in many cases used globally. They're an agreed upon set of rules or methods that allow interoperability between different devices. And some examples of open standards would be HTML, TCP/IP, and CSS. Everyone knows what the standards are for these. And so, for example, every web browser will meet the same standard for displaying HTML or CSS. Now, the benefits of open standards in general are interoperability, as you said before. They also encourage innovation. There's no barrier to entry to, for example, displaying CSS, or you don't need any specialized proprietary knowledge to create a device that can function on Wi-Fi. And so this can make it cheaper to create new and unique compatible devices, which encourages innovation. The next is longevity. If these are open standards that everyone's using, that means there's going to be a large and diverse community supporting and developing them, which means they're likely to be used for a long time. This means that if you create a device that works according to certain standards or certain protocols, that device is likely to be relevant for a long time in that respect. And finally, the last benefit of open standards is security. If standards and protocols are open, like for example, if TCP/IP, if the code that dictates what TCP/IP is available to everyone, then people can analyze those standards, and they can make recommendations to improve them and make them more secure. So you basically have more of a collective mindset towards security, with everyone who is making use of those standards contributing to making them more secure. Now, one of the most prominent organizations that's in charge of establishing open standards is the ISO, the International Organization for Standardization, which is an independent non-governmental organization, develops standards for software and hardware to ensure compatibility and interoperability across different systems and platforms. And it's also heavily involved with standards for network protocol, security, and communication, among many other things, even outside of the computing sphere. Like this, actually ISO, so this is not a huge part of the exam, but it's worth knowing what this organization is and what its role is. Now, finally, the last topic we're going to cover is the Creative Commons license, which strangely always seems to come up, and I'm not exactly sure why, but this is kind of more related to copywriting or copyright. And so Creative Commons license, in short, it's a type of copyright license that it's generally used not by large companies, but by individual creators to share their work online while they still retain some rights to them. So it's particularly used when people who are creating a piece of software or some type of work or creative endeavor in general want to make their work available to the public, but still maintain some control over how it is used. This is opposed to a corporation who does not really want any distribution of their content besides through their own channels. So generally, a Creative Commons license is used when there's more open attitude towards the distribution and usage of content, but with some limits. It allows others to use and share the work without explicitly seeking permission. Again, this is very different from like you trying to use clips from the Avengers, right? So you would need explicit permission to make extensive use of a film like that, versus the Creative Commons license, that's not necessarily true, as long as you follow certain rules. And there are different variations of the Creative Commons license. I don't think it's maintained by MIT. I believe that the standards are maintained or are specified by a non-governmental organization. But regardless, they can be enforced in a court of law. So yeah, a Creative Commons license for some reason is something that is relevant to the option C content. Okay, so let's get on with HL. So HL weirdly focuses on a number of disparate concepts. The first being graph theory, and then like ambient and collective intelligence, as well as something called the power rule. It's like a weird hodgepodge of concepts, but on the HL exam, particularly for paper 2, you're going to have one question that focuses on the HL content. The other 2 are generally still going to be just SL content. So let's get started. So graph theory, which is going to be the focus of most of your HL questions, is a branch of mathematics used extensively in the context of the World Wide Web. And when we're working with graph theory, we can represent the web as a graph, which means probably more of what you would think of, what you'd associate with a network. So we can view web pages as nodes that point via hyperlinks to other nodes or other web pages. So we'll have an arrow from one node to another node, that arrow being a hyperlink and those nodes being web pages. Now, graph theory algorithms are frequently used to analyze the structure and properties of the World Wide Web or of a subset of the World Wide Web. So we can say websites in general or groups of websites in general. Both the PageRank and HITS algorithm make heavy use of graph theory, particularly given the fact that they analyze outlinks and inlinks. So they're looking at the relationships and hyperlinks between different web pages. PageRank specifically looks at inlinks, while the HITS algorithm looks at both outlinks and inlinks. Now, the most common way to depict the World Wide Web or to depict groups of web pages is using the directed graph, which is also called a web graph. So as we kind of saw before, we have different nodes right here. So each of these might be a particular web page, and they all point to each other based on the website they link to. So for example, if 4 is pointing to 0, that means 4 must have a link to 0. If 0 is pointing to 2, that means that 0 must have a hyperlink that points to 2. Now, a specific way of depicting the directed graph or depicting the World Wide Web as a directed graph is called the Bowtie Model. Now, at first glance, it kind of looks like some sort of like alien monster or something. But it's composed of 5 separate components: the strongly connected core, which is the SCC, the sort of inlinks and outlinks, tendrils, and a tube. And once we understand what these do, this paradigm, the bowtie structure, makes a lot more sense. So in the center of the bowtie structure, which was referred to as the SCC, we have the core. And this is the central and most densely connected part of the web. It is made up of a small number of highly interconnected pages that form the backbone of the web. So when I think about really prominent pages that are connected to each other, news sites are often a good example. Reddit is actually probably an amazing example. But yeah, so generally on the web, we have a small core of sites that are densely connected to each other. And then we have in components. So these are pages that all have links to the core, to this like dense connection of sites, but don't have any links from the core to themselves. So they're usually important resources or services, but they're not central to the structure of the web. We also have out components, and these are pages that the core links to, but do not link back to the core. So while in components linked to the core, out components are linked to from the core. So there are links from the core to out components, to pages that are classified as out components, but they don't link back to the core. Remember, when we're talking about in components and out components, we're talking about web pages, just to be clear. So these could be sites that are dependent on the core for traffic, such as e-commerce or news sites. Now, next we have tendrils. And these are pages that can be reached from the in or out components, but cannot reach the core. They may be small, specialized niche sites that are not well connected to the rest of the web. So for example, a site that focuses heavily on nunchucks might be a tendril. Then finally, we have tubes. So these are pages that link the different components together. They could be directories, search engines, or other pages that provide navigation and connections between different parts of the web. So if you look at this diagram, we see the tube connecting the in components. Was it the in components or the in pages? The in components and the out components. We have the strongly connected core, and then we have our tendrils sort of on the periphery right here. So remember, in components are connecting to the core without any links back from the core, and the core links to out components, but the out components don't link back to the core. Okay, so now that we've learned about what a Bowtie model is, let's apply it to an example IB question. So the first question is going to be identify the nodes in the strongly connected core. So when I'm trying to figure out what nodes are in the strongly connected core, I kind of look at the graph and then I just look at which are one, connected in both ways, so which have inlinks to them and outlinks away from them, and which have more links to each other than anyone else. So just looking at this, 3 is going to be one of my picks, just because it has 3 links in total and in both directions. 6 is going to be another one, and I think 5 is going to be another one as well. The rest have fewer links, even though they're in both directions. So I'm going to say 3, 5, and 6. The next question is identify the set of out nodes. So remember, out nodes are those that have links from a node in the core, but don't link back to the core. So they'll have some link from one of the core nodes to them, but not back. So a good candidate would be 4. Let's use a different color right here. A good candidate would be 4, and another would be 8. Because both of these are linked to from a core element, but don't link back. So write 4 and 8. And outline why the edge between node 2 and 1 is a tendril. So this is telling us that this right here is a tendril. And the reasoning for that would be that 2 is connected, 2 links into an element, but 1 is linked away from 2. So it's not going towards the core, it's going away from the core. Hence, we can call that a tendril. Whenever we have an in or out, whenever we have an in or out node, and we have a link away from it, then generally it's going to be a tendril. So let's see what we got right here. We got 3, 5, and 6. Looks good. And then we have 4 and 8 for B, which also looks good. And we can say that I think the no here is referring to why 2 to 3 is not a tendril. It's because 2 reaches the node 3 that is in the SCC, which makes it an in node. So that being said, let's look at another question, given that these are the most common for the HL component of the exam. Okay, so let's cover one last question involving directed graphs, a more complex one, just to give you guys an idea of what a more difficult question would look like in this respect. So right here, first question is identify the nodes that make up the strongly connected core in the graph. Now, similar to the previous questions, I want to look for those that have the most number of hyperlinks and that go in both directions. So some candidates are going to be G, for sure, M definitely, I think L, and H. Now that being said, we also need to look at nodes that only connect to other core nodes. So K is a good example. I would say that D is a good example, A is a good example, and so is P. So we're going to go with, for A, we're going to go with A, G, H, D, K, L, M, and P. Now the next question is identify the set of out nodes. Remember, out nodes are going to be those nodes that are linked to from a core node, but don't link back. So E is a clear candidate, and so is N. However, because of the fact that I has links both from E and N, that by proxy makes it linked to from the core. So we're going to go with I as well. On the other hand, Q is not going to be an out node, because it doesn't, there's no way for a link to get from the core to Q. However, a link, like the core can be linked to I via E, which makes it an out node. Now, next question is state giving a reason whether the edge from J to F is a tendril. Now, so when we're talking about a tendril, we're typically talking about a node, or we're talking about a hyperlink that doesn't link to the core in some way. So this is J and this is F. Now F is definitely an in node. It's linking directly into the core. That kind of makes Jeff an in node by proxy, because we can go, or that kind of makes J an in node by proxy, because we can go directly from J to G to the core. Now if F was linking to J, So if there's an outlink to J, then we could say that that edge or that hyperlink would be a tendril, because there would be no way for J to get to the core from there, and it'd kind of be left hanging out there as it just on its own, similar to B. So the link from C to B could be considered a tendril. So the answer right here is going to be no. The last question is identify an edge that could be added to generate a tube, taking into consideration the existing nodes. Justify your answer. So when we have a tube, we want to be able to go from an in node to an out node, bypassing the core. So an edge that could be added to generate a tube, taking into consideration the existing nodes. I would probably have to say, this is actually a difficult one. So we're going to start with some in node. Okay, so we've got our in nodes. We've got our out nodes. I'd probably go from maybe J to O to Q. That could link into the out nodes. I wonder what the answers say with that one. Okay, so it could be CFJO, CFJO. Wait, is that really the answer? That's the answer. So any edge from one, so any of these to any of these. So we were right. We could actually have gone from J to O to, I guess Q is not an out node, so it'd have to be something like that. So let's go ahead and do that. So it needs to be from the out nodes to the in nodes, and Q is actually it's not an out node, it's actually a tendril in this case. So actually we need to go, so J to O was good, but it had to be to N, to one of the out nodes. Okay, so that kind of covers directed graphs and the butterfly paradigm. Let's move on to the last couple of slides. So one thing I want to look at is the concept of ambient intelligence. This is super random, but this is one of the last concepts. And so ambient intelligence refers to the integration of technology and the environment to create smart spaces that can interact with humans in a natural and intuitive way. So basically a smart home. It involves the use of sensors, wireless networks, and other technologies to create smart environments that can monitor and respond to changes in the user's environment. So if you think about a smart home system that uses sensors, machine learning, and other technologies to adjust lighting, temperature, and other environmental factors based on user behavior and preferences, basically taking the ambient factors into account and using machine learning to change the environment accordingly, that's ambient intelligence. Here's an example. The next kind, okay, so right here we have a question. I'm not really going to go into this too much, but it says discuss the technologies that ambient intelligence used in a specific scenario. This scenario is actually, involves street light intensity. Basically think about any sensor that monitors the amount of light and adjusts the street light accordingly, or monitors weather conditions or the time of day, any of the sensors that handle that and then adjust street light accordingly. The next concept is going to be collective intelligence. So collective intelligence refers to the ability of a group of individuals to collaborate and pool their knowledge, skills, and experience to solve problems. Collaboration, communication, and focuses on the idea that groups can achieve outcomes that are superior to those of even the most knowledgeable individuals. An example of creative or collective intelligence is going to be Wikipedia, or any crowdsourcing tools or social media platforms, which allow groups to share and collaborate. That's collective intelligence. So the last concept I want to cover is the power law distribution in the context of the World Wide Web. So this is closely related to the idea within our butterfly model that the idea of the strongly connected core, where we have a small number of pages that have a disproportionately large number of links. So the power law distribution, which is really a statistical distribution, represents that. So right here, if we look at the power law, we have very many nodes with only a few links. So we have, if you talk about the number of nodes, we've got a lot of nodes with a few number of links. And we have a few nodes with a huge number of links right down here. Okay, so this is going to represent the majority right here. And right here, we're going to have the minority. Versus if you look at a different distribution, like a bell curve, we would have a bunch. We basically have this scenario where we have Yeah, basically we have a few nodes, or we have a lower number of links for a few nodes, and we have a higher number of links for a few nodes. And everyone kind of falls in the middle into a sort of average. Versus here we have a different scenario where we have the majority, the small number of links, and a very small minority with a high number of links. So kind of the opposite of the sort of average situation of the bell curve is the power law distribution, and that represents the strongly connected core. And that's all you need to know about power laws. Now, this has been a long video. I kind of put this together at the last minute, hence some of the typos. I hope this still provided you with a lot of value. I think it's probably one of the only resources out there on option C, which is just a disparate and spread out collection of information. I don't know why all of it is in the same option. But anyways, if you found value in this, please consider buying or purchasing one of my study guides, which takes all this information, condenses it into a nice and easy to read packet of information. Additionally, please like and subscribe to this video. That being said, have a nice day and good luck.